In this video, we're going to talk about the future value of an ordinary annuity. Now, I'm going to give you the formula for the future value, and also we're going to do two examples. But actually, this formula, we derived this formula in the previous video. So we're just going to use it in this video without explaining where it comes from. Okay, it says the future value S of an ordinary annuity used to accumulate funds is given by this formula. Now S represents the future value. Remember when we were doing simple interest and compound interest, I think they used the letter A for the future value or the future amount. But for some reason, the book switches to using the letter S when we're talking about annuities. Okay, but it's the future value. And also remember when we were talking about simple and compound interest, they use the letter P to represent that initial amount of money you put in, the principal, right? That lump sum payment. But with annuities, you're not just making one payment, you're making regular payments. You're making lots of payments. And R is that payment that you're making. Okay, each payment period. Okay, the I, of course, represents the interest rate per period, and the N is the number of payment periods. Okay, let's do an example. It says find the amount of the ordinary annuity based on the information given. R is 400, so that's the payments that you're making each time. We have 6% interest compounded monthly for 25 years. Now notice one thing it did not tell you. It didn't tell you how often are you making this payment. Are you making this payment twice a year, once a year, 12 times a year, 365 times a year? Well, notice we're talking about an ordinary annuity. And if the interest is compounding monthly, then these have to be monthly payments. Okay, if it's really going to be an ordinary annuity, if the interest is compounding monthly, these have to be monthly payments. Okay, so let's start plugging things in. Notice that the R would be 400. The interest rate, I, is 0.06 divided by 12, right? So it's the interest rate. You have to take the 0.06 and divide it by 12. If we were talking about little r would just be 0.06. But little I is 0.06 over 12, which I believe this is 0.005. Okay, and N is the number of payment periods, basically how many times you're putting in this $400. Well, you're making 12 payments per year for 25 years, and 12 times 25 turns out is 300. Okay, so let's plug this in. We have 400 times, in parentheses or brackets, however you want to do it. In the denominator, we have 0.005. In the numerator, we have 1 plus I, which would be 1.005. raised to the 300th power, okay, and then minus 1. Notice I did not put parentheses around the 1.005. You don't have to do that. Now, if I had left it 1 plus 0.005, then that would have to be in parentheses. Okay, well, I think sometimes the hardest thing is figuring out how to type this into your calculator. Okay, what we're going to do is we're going to type in 400 times, and I'm going to use parentheses around the whole expression here. But what I'm going to do is put the whole numerator also in parentheses. Okay, so we're going to leave the bottom 0.005. The numerator will be 1.00 or 1.005 to the 300th minus 1. Okay, that will all be in parentheses. Okay, so let's work that out on a calculator. Okay, so let's turn this on and clear it. So do 400 times, okay, in parentheses, and then another parenthesis, 1.005 raised to the 300th power, okay, then minus 1, oh, made a mistake, right? This minus 1 should not be in the exponent, right? So we should go back and delete these, and I need to get down to out here, so let's press out here. So we now get minus 1, okay, and then end the parenthesis for the numerator, divided by 0.005, and then end the other parenthesis and hit enter. And then notice $277,197. Okay, $197,197.59. Okay, that's the future value of this annuity. Now, does that seem like a reasonable amount? Well, you could check a couple things. Notice, if you made no interest at all, how much money would you have in the account? Well, you're making 12 payments each year of $400 for 25 years. Essentially, you're making 300 payments of $400. And 300 times 400 turns out it's 120,000. Okay, so if you made no interest at all, you'd have 120,000, and so with 6% interest, you should have definitely more than 120,000. Notice we have a lot more, but that's okay. It sounds reasonable because a lot of these early payments, they're accumulating interest, right? They're compounding their interest for a long time, for 25 years. So yeah, that definitely sounds like it could be reasonable. Okay, let's do another example. It says a rookie football player in the NFL just signed his first 7-year contract. To prepare for his future, he deposits $150,000 at the end of each year for 7 years in an account paying 4.1% compounded annually. How much will he have in the account after 7 years? Now notice we have an ordinary annuity. He's putting his money in at the end of each year. It's compounding annually, and he's also putting it in once a year. And the payment amounts are the same. It's not changing. It's $150,000 every time. Okay, so I just put the formula there. Let's start plugging some numbers in here. So notice, what is the R? The R is $150,000. Boy, I wish I had $150,000 to put in a retirement account every year. But anyways, the I, what is the I? Well, it's 0.041, right? That's 4.1%. Now you're doing it annually, so all you really have to do is just divide by 1. Okay, it's not like it's a monthly payment, it's annually. So anyways, it's really just 0.041. And the N is the number of payments that you make, the number of payment periods, right? Well, you're making one payment a year for 7 years, so 7 times 1 would be 7. Okay, so let's plug things in. We have 150,000 times, it would be 1.041 raised to the 7th power minus 1 divided by 0.041. Okay, so the way we would type this in our calculator would be 150,000, okay, times, we'd still have 0.041 in the denominator. In the numerator, we'd put the whole numerator in parentheses as well. Okay, we don't want the calculator to just think we're doing 1 over this. We're doing the whole top part over 0.041. Okay, so let's try this. Type this in our calculator here. So we have 150,000. Okay, times, okay, double parentheses there, 1.041 raised to the 7th power. Okay, make sure to get out of there and get the minus 1 down here, not in the exponent. Minus 1, okay, and 1 of the parentheses, divided by 0.041 and the other parenthesis, and hit enter. Notice that's boy, that's a lot of money. 1,188,346. Okay, 1,188,346, and he probably doesn't care about these extra pennies, but and 11 cents. Okay, so that is the future value of this annuity. That's how much money this player would have in this annuity at the end of the 7 years. Now, does that seem reasonable? Sometimes it's just good to check. Does this number seem reasonable? Okay, well, what if he didn't get any interest at all? I like to think of it that way. Suppose he didn't get any interest at all instead of the 4.1%. Well, he's making 150,000. You're putting in 150,000 dollars 7 different times, and if you type in, let me type in my calculator I have here, 150,000 times 7, it ends up being $1,050,000. That's how much money he's putting in. But notice, how much money does he have in the annuity at the end? He has a $1,188,000 and some extra money. So notice he made about $138,000 by putting it in here, as opposed to just, sticking the money under his bed, under the mattress. That's never a good idea, especially $150,000. But anyways, that's the future value of that annuity.